Hi friends, this video we are going to see testing hypothesis. What is a testing hypothesis? A hypothesis test is a process that uses sample statistic to test a claim about the value of population parameter. A statement about a population parameter is called statistical hypothesis. So generally we are going to test, at the time we are using the testing hypothesis. To test a population parameter, we should carefully state a pair of hypotheses. First one is represent the claim on that represent the claim and the other its complement. So we have the name of that each one. So that is first one we called as a one is null hypothesis. This is always true. That is first one is null hypothesis. It's always denoted by H naught. Another one is, second one is alternative hypothesis. So what is the null hypothesis? Null hypothesis is a statement that assumes no effect. The null hypothesis means it's a statement that assumes no effect or no significance. Okay, but alternative hypothesis, that is only we always going to claim, so our own results. The alternative hypothesis is a statement that contradicts the null hypothesis. Okay. So what is the meaning? It has some effect. Okay, it has some effect. The null hypothesis is always denoted by H naught. Alternative hypothesis sometimes denoted by H1 or HA. H1 or HA. Some people use the capital also. This is the alternative hypothesis. Okay. Next, we are giving the what is the type 1 error. So what is that? So we reject the null hypothesis. We reject the null hypothesis, that is our H naught. But when it's actually true, is called type 1 error. What is the type 2 error? So one means there is another error with that is type 2 error. We do not reject null hypothesis. We do not reject the H naught when it's actually false. So in null hypothesis, we had the type 1 error and type 2 error. The probability of committing type 1 error is we denote as alpha. That is probability of type 1 error is denoted by alpha. So that is we called as a, this is also called as level of significance. Okay. So type 1, the probability of committing a type 1 error is called as level of significance, is denoted by alpha. The probability of type 2 error we denote as beta. The probability of type 2 error is denoted by beta. In hypothesis testing, we have two ways. First one is one-tail test. Second one is two-tail test. What is by one-tail test means you are going to your null hypothesis. We are going to discuss about our alternative hypothesis. So a test of any statistical hypothesis that is our alternative hypothesis only. Okay, H1 is one-sided. Okay, that is one-sided means our H1 is theta is greater than theta naught. So what about the null hypothesis is H naught is theta equal to theta naught, or our H1 is theta is less than theta naught. So our null hypothesis theta equal to theta naught. This meaning is, suppose we are our alternative hypothesis greater than theta naught or less than theta, mean we are called as a one-tail test. Especially this greater than 1 means we called as a right tail test. This one is less than means we call less than left tail test. So both are one tail. So it will have the subcategory. First one is left tail, another is a right tail. The same way in two tail test means a test of any statistical hypothesis. Hypothesis where H1 is two-sided. That is, your H1 is, I choose it as theta is not equal to theta naught. So what about the other hypothesis? Theta equal to theta naught. So this meaning is what? This meaning is theta value is, what is that this one is says? That is theta is less than theta naught or theta is greater than theta naught. Okay, that is why it's two-sided. Clearly you say we are one-sided or two-sided, it's always determined by your H1, not your H0. Correct? H0 is, please noted, everything is equal symbol only. So that is our assumption. Okay. Whenever the null hypothesis it has equal symbol only. This less than, greater than, not equal from our alternative hypothesis only. Okay. So now we are going to see test of significance for mean. That is our main aim. Test of significance for mean. Okay, this is something. So it has two cases. First one is sigma is known, and second one is sigma is unknown. What is the sigma? A sigma is population standard deviation. So whenever we test of significance for mean, we have the two cases. First one is sigma is known. So the first case is sigma is known means we are going to see the formula is Z equal to x bar minus mu divided by sigma divided by square root of n. Second case, if sigma is unknown, your Z is equal to x bar minus mu divided by s divided by square root of n. Okay, this is the very clear mind. Here what is the x bar? X bar is the sample mean. Here x bar is x bar is sample, mean, and S is sample standard deviation, and N is number of sample. Okay. Test of significance for mean is, it has two cases. First one is sigma is known and sigma is unknown. Sigma is known means you want to use the formula x bar minus mu divided by sigma divided by square root of n. If sigma is unknown means you want to use z equal to x bar minus mu divided by x over square. We see how to reject and how to not reject the h naught. We will see first left tail, that is you calculate the z alpha, then calculate the z using the formula. So suppose z is greater than minus z alpha, you not reject h naught. If z is less than minus z alpha, then you reject the null hypothesis. That is, you have the some, so this is your standard, this is your standard normal distribution z table you will get. Suppose you have the value that is minus z alpha, your z alpha means less than this value, this region only reject region. Correct? This is reject region. This is a not reject region. So whenever z is, so z minus z alpha is this value, your z is located here, in this value will come here. Now you will take reject. Suppose your right tail test means you have that, you have the standard deviation, that is reject table. This is your rejected region. Okay, this is your z alpha. In this region means you are rejected. So you get together, you can, whenever the both side test means you take the absolute value both side. So both side absolute value is less than, your calculated absolute value is less than the table z alpha, then you say it is not rejected. If not z is greater than z alpha, you reject the h naught. The two tailed means you take whenever you have the alpha. This is standard. Okay, this is the z alpha by 2 minus the alpha value. It is plus z alpha divided by 2 minus z alpha by 2. So these are the reject region. These are not reject region. Here and here are reject. So whenever whenever the alpha is given, you find the minus z alpha by 2 and plus z alpha by 2. Okay, you can say that whenever minus z alpha by 2 less than z alpha by 2, not reject h naught. Whenever z is does not belongs to this region, then you reject h naught. Okay, that is mod z is less than z alpha by 2 mod z. Correct? Then you reject the null. You not reject the null hypothesis. Whenever mod z is greater than z alpha by 2, you reject the null hypothesis. Now we see few examples how to reject and not reject the null hypothesis. Now we see first example. A random sample of 100 recorded deaths in US during the past year showed an average of 71.8 years. Assuming a population standard deviation of 8.9 years, does this seem to indicate the mean life span today is greater than 70 years? Use 0.05 level of significance. That is the problem they given. What is they given means the last year some 100 deaths they have that is a sample they taken. So their average year is 71.8 years. So then they already known about the population standard deviation is 8.9 years. I can say the mean life of span is more than 70 years. I can say using this data. That is my problem. So I want to say greater than 70 years. That is the lifespan of one person is more than 70. I can say or not using this sample. That is my question. So first we proceed with, we write what are the given first step. What are the given we first write, then we write our formula, then first we write the, what is the given. First of all the given is n equal to, that is sample size. Sample is 100. So last year so many people will die, but we are taking only 100 people only. Then there, this is the number of people sample. This is the average. That is, what is the average? Average of that sample. So we choose that is our x bar. X bar is 71.8. That is the given. Assume a population standard. This is not a sample standard deviation, is a population standard. That is sigma is 8.9 years. Correct? So what do you want to say? This is the given. Okay, this is a given. Next is I construct the hypothesis. So what is my claim? I claim that it's greater than 70 years. So that is, my claim is always denoted by H1. H1 is shows mu is greater than 70. So what is the null hypothesis is? Null hypothesis is mu equal to 70. This is automatically, this is left tail or right tail? This is right tail. Okay. Now I am using the formula. What is the formula? Z equal to x bar minus mu divided by sigma divided by square root of n. What is mu? Mu is, so x bar is, we already know x bar is 71.8 and your mean is 70 years. So you want to prove that more than 70. This one only I choose as our mean value. Correct? So using that x bar is 71.8 minus 70 divided by 8.9 divided by square root of 100. So if you are using this value in the calculator, you will get Z equal to 2.02. Next step, I want to find what is the meaning of 0.5 they given. Correct? So what is the 0 point significance means? That is, I want to find Z alpha. Z alpha means you want to find where is the value of from the table. Z alpha value you have to evaluate from the statistical table. So Z alpha value is what will come is 1.645. From this is from our table, from statistical table. Okay. So clearly Z is greater than Z alpha. So what do I conclude? z is greater than z alpha, we have to reject the null constraint. So reject the null hypothesis. So we are rejecting, correct? So reject the null hypothesis. So we can conclude that the average life is greater than 70 only. Okay, that means we are reject the null hypothesis. Okay, in this problem they given what is the standard deviation. Okay, so this way we are using. So whenever we are reject means z is greater than z alpha means you have to reject it. Z is less than z alpha means we have to accept it. Fine, or not reject the null hypothesis. Okay, next step, if you are knowing if this example they given the what is the standard deviation. Okay, in this next example we are going to see. In this example, the insurance agent has claimed that the average policyholder who insured through him is less than 40 years. So he is less than 30.5 years. A random sample of 100 policyholders who had insured through him revealed that the mean is 28.8 years and standard deviation is 6.35 years. Okay, so I am using the alpha value is 0.05 significance. If they didn't give the problem, you assume that alpha equal to 0.05. So what is the problem they given? The insurance agent claimed that the average year is less than 30.5 years to the random sample of 100 policy holders. So the sample mean is 28.8 and the standard deviations are 6.35. These are the given, correct? I will solve this problem. First step I will write what are they given first. The given is x bar is 28.8 and s equal to 6.35, n equal to 100 and mu is 30.5. So he want to claim that your is less than 30.5 years, correct? So your H1 is mu is less than 30.5. Then what is the H0? H0 mu equal to 30.5. So in this problem they didn't give them what is the standard deviation of the population, but they give only the sample standard deviation. So in this case it's under the category of the second case. So Z equal to the formula is x bar minus mu divided by s divided by square root of n. This is the formula I have to use. What is the x bar? X bar is 28.8 minus mu value is 30.5 divided by 6.35 over 10. If you are using your calculator, you will get the value is minus 2.68. Okay. So what is the Z alpha value is? Z alpha value is from the table we can find 1.645. So this is left tail or right tail? This is left tail. Okay. So you want to check it, that is mod Z is greater than reject alpha. This implies, what you want to say? You are going to reject the null hypothesis. Reject null hypothesis.